And when we took our break, before break, we talked about how to plug numbers in, how to find those requested values. So like on that first one in your homework, out of 2.6 here, we wanted to find f of 6. Now, we don't plug 6 into all 3 rows. We only plug it in the row where it goes. So which row would it go into? Is 6 less than 1? Nope. Is 6 between 6 and 10? Yep. It equals that 6, so you'd plug it into the second row. This one would be for values greater than 10. So 6 is definitely not greater than 10. So you would plug it into that second row. You only have to plug it into one row. It only goes into one row. So figure out which row it goes into, plug it in, and find your value. And that's that first one where we want to find the requested value. The next ones are going to be graphic. When we go to graph these, we have to plot points, and then we connect them together. So we're now going to try and graph this piecewise defined function. And how about we graph f of x? We'll do one with two, probably two of these, with just 2 rows, and then we'll do one with 3 rows as well. So let's say our piecewise defined function is, let's say, 2x squared if x is, let's say, less than or equal to -1, and 5 if x is greater than -1. And what we want to do is we want to plug values into each of these rows. And we're going to get points. We're going to then connect them together with the basic shape of the graph. Now, we do also need to remember what gets an open circle and what gets a closed circle. So strictly less than, strictly greater than, those get an open circle. Greater than or equal to, less than or equal to, those are going to have a closed circle. So when we go to graph these, we've got to remember what has the open circle and what has the closed circle. So the first row, it is less than or equal to, the equal to bar underneath means that that first row is going to have a closed circle. The second row is greater than -1. There's no bar underneath, so it's going to have an open circle. So the first one has a closed circle. The second one has an open circle. And we want to get at least 2 points in each row. So we're going to start with row number 1. Now we always begin by plugging in the value that's given here first. And then we find another value after that as well. So we plug in our -1 first because that's the value that we're given. So in row number 1, we're going to plug in a -1. And if I plug into row number 1, -1, what do I get? I get 2 times a -1 squared. -1 squared is 1, times 2 makes it 2. So my first ordered pair then is going to be -1, +2. We need another value, and we need to make sure that it falls in row 1. Now, row 1 is for numbers that are less than -1. Less than or equal to -1. We already plugged in the -1, so we need a number smaller than -1. So how about we use a -2? If I plug that -2 in, then I have to square it and multiply it by 2. And -2 squared is 4, times 2 makes it an 8. So my second point is -2, +8. So there's our 2 points. So we're going to go ahead now and plot these 2 points and begin graphing our function. So the first point that we need is -1, +2. So that's back 1 and up 1, 2. And we use a closed circle here. And I always like to label that first point, at least label the first point. And that point is going to now be -1, +2. My second point is -2, comma, +8. So there's 2, 3, 4, 5, 6, 7, 8. So it's going to be clear up here. And that's at -2, 8. Now, when we connect them together, remember when we covered the squaring function, we didn't have a straight line to connect them together. What did we use? We used a curve. So we're going to kind of curve these together. That's why we had to know the squaring function first. It looks kind of a curve, just like that. And it's done in pieces. So the first row I'm going to do in green here. The colors may not show up the best on the screen, but that's our first row. And we plotted our 2 points, made our curve. What about the second row? Well, for row number 2, we plug in our values. And we plug in a -1. Now, row number 2 is a constant function. So it doesn't matter what we plug into row number 2. What do we get out? 5. It's a constant value. So if I plug in -1, what do I get out? 5. And what is that ordered pair now? -1, 5. We need another one in that row. Row 2 is going to be for values that are bigger than -1. A number bigger than -1 would be 0. And again, if I plug in that 0 into the second row, it's a constant function at 5. So that would give me my second ordered pair, which is 0, 5. Now we'll plot these 2 points. And your graph is going to be done in pieces, so they're not going to match up. It's going to be 2 separate graphs put together. So -1, +5. So there's 2, 3, 4, 5. And that's going to be right here. Again, it gets an open circle. So an open circle at that that -1, 5. And then we need another point at 0, 5, which is right here. And when we connect them together, they make a straight line. So they make a horizontal line, just like that. There is your graph. They're done in pieces. They look a little bit different than the graphs we've done before because they have to be done in separate pieces. The key part, though, is to note that row number 1, what did it have? It had a closed circle, right? Row number 2 has that open circle. And I plotted my points and then connected them together. They're separate graphs, so don't try to connect all the dots together. Just the 2 that go on each row together. Let's try another one. Same type of function here. Let's say, and what we're doing is we're graphing this one. So we're going to try and graph f of x, and this is a piecewise function. So how about we use 4x minus 1 if x is, let's see, last time we used less than or equal to, how about less than 2? And 2x if x is greater than or equal to 2. And this will be row 1. This will be row 2. And row 1 doesn't have a bar on it, so it's going to have an open circle. Row 2 has that bar again, so it'll be a closed circle. So one's an open circle, one's a closed circle. We now put values in. We need 2 points for each row. You can have more, but we really only need 2. So when we look at row 1, we always begin with the provided value. So it has a 2, so we're going to start with 2. So we're going to plug in x equals 2. And if I plug that into row 1, I get 4 times 2 minus 1. So that's 8 minus 1, which is a 7. And so my first ordered pair is 2, 7. We need another point in row 1. Now, what does row 1 say? It says we want values of x that are what? That are less than 2. So we need a value that's less than 2. We can use 0 or we can use 1. Doesn't matter. I'm just going to use 1. So we're going to plug in that 1. And that's going to be 4 times 1 minus 1. And that gives you a 3. So now my second point for the first row is 1, 3. Now we've got everything that we need to graph that first row. And we know that first row, again, it gets an open circle. So our first point's an open circle. So 2, 7 is over 2 and up 7. 4, 5, 6, 7. So 2, 7 is right here with an open circle. My next point is 1, 3. So it's over 1 and up 1, 2, 3. Now, this is a linear function, right? 4x minus 1, that makes a line. So when we connect these together, we're not going to use a curve because it's not a square. We connect them together with a line just like that. That's half of it. That's our first row. Now we repeat the process with our second row. And we plug in R2 again. So you plug in the number that's provided on the end, and it's going to have a closed circle on this one. So we plug in 2. And if I plug in 2, then I get 2 times 2, which makes it then 4. So my first ordered pair for row 2 is 2, 4. We need another point in row 2. Now row 2 is going to be for values that are bigger than 2. So we need a number larger than 2. We can use 5, we can use 8, doesn't matter. I like to keep it as small as possible. So we're going to use a 3. If I plug in that 3, then I get 2 times that 3. That makes it 6. And my next ordered pair then is 3, 6. So we find our 2, 4. So it's over 2. And up 1, 2, 3, 4. So it's going to be right about here. And it's going to have a closed circle. So 2, 4 is right here with a closed circle. And the open and closed circles should be on top of each other too. And all these will be on top of each other. What's my next point? 3, 6, so that's over 3. And then up about 6, so it's right about there. And now we can connect them together. And this again is a line. So I'm going to connect these together. And that is my graph. Make sure you notice where's an open circle and a closed circle. See how it has to be done in pieces. These have to be done in separate pieces. They look a little bit different because they're done in pieces. So we've so far seen how to do these with 2 rows. Now we're going to move on and we're going to look at one that has 3 rows. We'll do the same process. And we're going to have to pick 2 points in each row. So we're going to have to get 6 points total. So how about we try to graph this one? And let's try and graph f of x. And this one's going to have 3 rows. So let's try and graph x minus 1. If x is less than or equal to 0, 5 if x is between 0 and including that 4. Let's use a 4 here. And then let's use another one. How about minus 3x? If x is greater than 4. And again, we've got, in this case, not 2 rows, we've got 3. Identify what gets an open circle and what gets a closed circle. Row 1 is less than 0, less than or equal to 0. So if it's less than or equal to, it gets a closed circle. Row 2, the left part has no equal bar, so it gets an open circle. However, that 4 is less than or equal to 4, so that side's going to get the closed circle. And then the last one, greater than 4, that means we have an open circle. Okay, so now we're going to graph each one of these individually. And we're going to start with row 1. We plug in that value that's provided, so we plug in that 0. So row number 1, we plug in x equals 0 here. And that's going to go in row 1. And when we plug in 0, what do we get? We get 0 minus 1, which is a minus 1. Now my ordered pair is 0 minus 1. We need another point. You have to have 2 for each row. And if we want values that are less than or equal to 0, we already used the 0. So we need the next smaller number from 0. So we'll use a negative 1. If I plug in that negative 1, then I get minus 1, which makes it minus 2. So I now got minus 1, minus 2. So I'll make this graph a little bit bigger so we can see what we've got. So we plot our points. We've got 0, negative 1, which is here. Then we've got negative 1, negative 2. We connect them together, and what do we use? On our first part, we use a closed circle. So we need a closed circle right here at 0, negative 1. This is a line, so they're not going to be a curve because it just got an x, so that's a linear function, and that makes that piece. So there's one part of it. And I'll go ahead and label these 1, 2, and 3. So there's your first row. We got that one. Now we'll go up to our function again. And what do we need now? We need row number 2. And what do we know about row number 2? Well, row number 2 is a constant function at 5. We're going to plug in x equals 0. And if I plug in 0, what does that give you? It's a constant function, so that gives you 5. So that is then the point 0, 5. Now, whenever it's trapped in between them, what you do is you do each side. So we'll do the 0, which we did here, and the other side, which was that 4. So we're now going to plug in that 4. And if I plug in that 4, it's a constant function again at 5. So that makes it 4, 5. Now we'll go to our graph. It's hard to keep it all on the same screen. This is going to be our row 2 again. Now, row 2, we need an open circle at the first point, closed circle at the second. So we need 0, 5. Sorry, our first point here is 0, 5, and it gets an open circle. Our next point is at 4, 5, and it needs a closed circle right here, because one side was open, one side was closed. And then we can connect them together to make the middle region. So that one's open, this one's closed. Now, again, do we know what gets what? Well, the first point gets the open circle at that 0. 4 gets the closed circle. We need one more row here, and that's row 3. So we go back to our function, and we need 2 values again. So we always plug in the value that's provided first. So we're going to plug in row 3 here, row number 3. We're going to plug in x equals 4. And if I plug in that 4, then that is minus 3 times 4, which is then a minus 12. So my first point for row 3 is 4, comma, negative 12. We need another value bigger than 4. So we'll use a 5. It's the next larger number. And then that's minus 3 times 5, which is then a minus 15. So my next point is 5, comma, negative 15. Is everyone kind of okay with what we're doing? Just plug in the values. Okay, and it's going to be done in pieces. So don't think it's all one continuous graph. It's discontinuous. And just so we know, that was 1. This one was 2. Sometimes it's helpful to label them. So that's your part 2. What about row 3? Okay, row 3, we have 4, negative 12. So we're going to have to go down 12 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's way down here at the very bottom. And over 4, so it's going to be right about there at 4, negative 12, and it has an open circle. So you've got an open circle there. It should be directly on top of the closed one. And it is. The open and closed circles should always be on top of each other. Our next point is 5, negative 15. So we're going to have to go down 3 more. Okay, so there's 12, 13, 14, 15. And over about 1, so it's going to be right about there. At 5, comma, negative 15. And we'll connect those together. And now we have our entire graph. Okay, so there's our entire graph. And again, these have to be done in pieces. Students struggle the most with these, but if you just plot the points and connect them together, you'll get your graphs without much of a struggle. So now let's move on And now I'm going to do the opposite. So now I'm going to give you a graph, and you're going to have to find the function that it came from. So I'm going to give you a picture, and we're going to have to figure out what function this came from. And then we're also going to get the domain and the range. So we're going to find the function and get the domain and range. So that's what we're going to be doing here. Okay. Now, the one on the left is your first one. So this is going to be row 1. We always write the left first. We read from left to right. And this will be the second one. So that's the way we read them. Now we need to come up with our function. So it's going to be a piecewise defined function. And the first thing we need to do is we need to figure out where it switches from one function to the other. And this switch is going to be on the x-axis. So where does it switch between one function to the next one? On the x-axis, it's going to switch at what? 3, right? Because this one is at down here at -2. And then what does it do at 3? When it hits 3, it goes up to the next row. So where does it switch at? It switches at 3. So our first one is going to be if x, and we're looking at the left, so if x is now less than or equal to 3, because it has a closed circle here at 3, our first row is right here. You always work from left to right. And so we're looking at x less than or equal to 3. What about our other one? Well, our other one is if x is going to be the opposite, and it's going to be greater than 3, because it has an open circle. So that means it's strictly greater than 3. Now, these are constant functions. So if we're at row 1, what is our y value? We're looking at the y value. This is a constant function at what? If we look at it, it looks like it's at what value across here? Constant function at y equals what? -2. Okay, so that's going to be our function, -2. What about the second row? So this is 1. This is 2. Well, it's a constant. And where is it a constant function from? Or at, I should say. It's a constant at what? 5. So there is the function that gives you this graph. We also need to get our domain and our range. And when we talk about the domain, domain is values of x. So that's the left and right. Now, does this function go back to the left? Yes. Does this function go to the right? Yes. So my domain would be negative to positive infinity, because it goes to the left, it goes to the right. The range is the y part, the up and down part, and it's different. When we talk about the range, the y part, look at my two functions. Whenever I plug values in, my functions are either at -2 or what? 5. So my range would simply be the two numbers -2 and +5, right? Because it can't be anything else. It can't go up or down any, because this is our graph here. Okay, so your domain is left and right. It can do all those numbers. The range, though, is up and down, and it's either at -2 or it's at +5. We'll do one more of these, and then that's going to finish up 2, 6. So we'll do one more of these, take a break, come back, and do 2, 8. We already did 2, 7. We did that earlier. So one more of these, we have to find the function. So I'm going to give you another picture, and we're going to try and find the function that it came from. Okay, so we're going to find the function and the domain and range. Always work from left to right. So this is 1, and this is 2. So first thing we look at our transition, and where does it switch from one function to the other? On the x-axis, it switches at what? 0, doesn't it? Right? Because 0 is where it switches. So I'm here at 1, and then when I hit 0, what happens? I go up to the next row. Okay? So it switches at 0. Now, row number 1 is for values of x that are less than or equal to 0. Row number 2 is for values of x that are bigger than 0. And in your homework, you're not going to get anything complicated to find the function. They're going to look like this. The graph will look like that. Very, very simple. Question 3 in your homework is pretty much the same thing. You got a picture. You find the domain, range, and the function it came from. So we've got our x values labeled, our conditions. We should put the if there. And row 1, where's it stuck at? It's stuck at 1. And row 2, what's its value? 6. So there's your piecewise defined function. Our domain is always the same on these. So my domain is negative to positive infinity, because you can go to the left and you can go to the right. And what about our range? Well, our range is stuck at 1 or what? 6. That's it. So let's take a short break, and let's meet back here at 8:35, and then we'll cover that last section.